Hey everyone. So today I'm going to take you through two different ways of reading in CSV files, or Excel files. So perhaps in your application you have a lot of data and you want to organize that data into an Excel file, and you want to be able to look at that data with your program code. So I'll show you two different libraries. The first one we're going to look at is CSV, which is Python's built-in CSV library. Uh, it's used for uh, basically only comma-separated value files. You can't actually read full Excel files in with it, so it does have some limitations to it. I think Pandas has a lot more built-in functionality, so I would suggest using that if you are using bigger data. But if you just need something to read in a file, get the data into a dictionary, CSV will work just fine. The nice thing about it, it doesn't require any other dependencies, so you don't need to worry about having that library installed as well with Python. It should just run. So let's look at that first. The first thing you'll need to do is import CSV, which is the library we're going to be using. And then we're going to do the same notation that we've been doing with open and the file name that we're doing. So I've created a test CSV comma separated value file that I'm going to be opening, and we just do as file. And then we can say something like data equals csv.reader of the file. So I'll just run this code and show you what this would look like. Oh, we actually didn't do anything with it yet. All right, and let's print out the data. So let's see what this reader does. Okay, so it creates a CSV reader object. Not super useful to see in the console output here, so we'll have to use an iterator to go through this. And so let's go through and say for each row in the data, let's print out that row of data, and then we can run our code again. And now our output looks a lot nicer here. So you can see my CSV file that I have test here is just some statistics actually. So we have a file here. Line 1 is our header, names, goals, assists, points, and then 4 different players in their stat lines. And we can see that printed out. And the way the CSV reader works is it reads it in line by line, and each line it makes a list where each value is indexed according to which column it's in. And so, if the goals are in column 1, names are in column 0, then you can, go through this row by row. You can go through each row in the data, and you can, calculate how many total goals there are or how many total assists there are, something like that. Whatever it is that you might need this for. So this is useful, but I think there's actually a nicer way of reading in this data if you want to actually do some manipulation with it. So I'm going to comment that out. But again, if you just want something quick and easy to just display the data, this is a pretty easy way to do it. Another function we could use is this dictionary reader class. Same notation, but we're adding that dictionary in front of it. And what this is going to actually look a little bit different. If we print out the data now, you see it just changed the type of the object from a reader now to a dictionary reader. And so if I do the same notation here, you'll notice a couple things. First of all, we have these things called ordered dictionaries, and this is just what's actually keeping these elements in order, so that the name is in column 0, the goals are in column 1, the assists are in column 2, and then the points are in column 3. Otherwise, dictionaries are not ordered, and so then we would have the columns being switched up and things like that. But you'll see that it actually has it key values each of these pairs in the files. So if I want the name, you notice that the name, the goals, the assists, and the points were the things in my first header right here. And those show up as the first element here. And then each one corresponds to, so for the name, it corresponds to the first element in each of these rows. The goals is the second, And so it actually pairs this data together and makes it a little bit easy to use. So for example, if we just wanted to see the names, I could then say print out the names only, and it will just print out as we go through the names of each of the players. If I want the name and the points, I think I got the key right. I did not. What's the key? Maybe there's a space or something in the file. Second. Sorry about that. Let's see. There's some space error here. You can see I actually have that in front of goals, assists, and points. Let me fix my key values here. I guess put the space in front of these. I guess you shouldn't have any white space whatsoever in your CSV file. And I accidentally put in white space when I made this up. So then we could do row, and now this should work. We do points, and it just prints out the point total. So you can sort through data that way. Again, getting just the information that you need. You could save all this data into some sort of a dictionary and then actually go through it. So this is going through each row. Each row in itself, going back to just printing and displaying the row, each row itself is an ordered dictionary. So you could keep you could keep each row and you could find it, and it works out pretty nicely. So this is a really quick and easy way of doing it. And there's a lot more that you can use with this. If you are curious, search up CSV dictionary reader, and there's some more methods there. So let's say, for example, we're looking for a particular player in our list. Then what we could do is as we go through the data, we could say, if the name of that player is Alice, then let's print out just that row. And you'll see it only prints out the row that includes Alice. If we search for, player X, then and player X isn't in our database, then it will not print out any of our results. So we can then search through data. Maybe we're saving usernames and some account information, and the player is trying to look at their account information. We want to display that account information for them. Then we could, store all this into a CSV file. A lot of times when you register an account, they'll ask date of birth, they'll ask, for an email address, whatever, a screen name. So maybe we have all this data stored, and if we want to only display the information of that particular player. If they type in their account name wrong, then we would obviously get no results returned for them, something like that, right? So again, there's some uses for this. I'm going to show you something that's a little bit more practical that I did with this CSV reader, and hopefully you enjoy it. I'm just going to take a second to pull this up here. So here what I have is actually a program that I wrote that we were maybe going to do together, but unfortunately weren't able to. So in this, I actually took some real data from some different websites and mashed it together and made something that I thought was pretty interesting. So if you've heard of the Indigo bike share company, what they have basically a whole bunch of data on their bikes. So they're a bike sharing company, which means you can basically rent a bike and like you'll check that bike out at one station, drive it around, check it into another station. And they log basically every time that bike is checked in or checked out, what time of day it was, how long the user had the bike out, all these different things. And they put all of this data and make it actually publicly available. And I actually thought this was pretty interesting. And so what I did was I took this data and I mashed it up with some weather data. There was another CSV file that I found that had all of the temperature and weather, like whether it was rainy, cloudy, sunny, whatever the temperature was, whatever the condition was, um, a bunch of different cities every single hour for like 5 or 6 years or something like that. It's an insane amount of data. And I basically took these two things, these two ideas, and I wanted to see, what percentage of bike rides happened when it was sunny versus when it was rainy, something like that. And I wrote and I used this CSV library to help me do that. And so this is what this code does. I do want to show you the CSV files. So I'll pull those up first, just so you get an idea of what type of data we're looking at. Okay, and so here I have it pulled up. This first one's the bike data. You can see here it's got a whole bunch of data. This is the start time, the end time. For a trip, each trip has its own ID. It has a duration. It has a starting latitude and uh, station ID, starting longitude, end station ID, end latitude, end longitude. A lot of the times these station end and beginning IDs are the same. Sometimes the bike actually moves from one station to the other. It has a bike ID itself, so you could actually trace one bike. You just looked by its ID and see where it went. You can see if the trip was a one-way or a round trip. One-way trips, the end and beginning station IDs are different. And so there's all this different data. And so then another file I have, this is, again, the temperature data. So these are all temperatures in Kelvin. I don't know why they put them in Kelvin, but that's the format they're in. They have a date time. And you'll notice this is a little bit different format of the date time, and that comes into play later on. And we have all these different cities, but we do have Philadelphia, and that's the one that we're going to be using. So, and I'm just going to scroll here just to show you the vastness of this data file. I'm going to go all the way to the bottom of the file. This is now at, let's see, 452,000 lines of data. It goes all the way to November 30th of 2017, and it started all the way back at October 1st of 2012. So basically 5 years plus a month of data. And then the weather data is right here. Same idea, same date, month, but now it tells you what the weather was like. Sky is clear, broken clouds, overcast, and you can just see it's just a crazy amount of data. And to try to go through this, by hand, it's impossible, right? We need computers to do this. All right, so then I'll go ahead and I'll look at the code with you guys. So here's the code we have. So what's the first thing that I do? Well, I want to actually open up all three of these files together. So I open up the weather file, I open up the temperature file, and I open up the bike data file. Then I go through the bike data, and I grab the headers from that. And this was so that I could get the date and the time. And then I grab the and basically what I'm going to do is I'm going to output, and I'm just going to make a new Excel file that has the bike data, but I'm going to put the weather and the temperature data in that file so that we might be able to see some stuff. And that's all this is doing. So it's reading in the data here, and basically I'm just using this. I'm going through the times one time at a time, and it's not real important how it all works out. If you're curious, you can kind of pause the video and look through some of the code. I do have to convert the temperature from Kelvin to Celsius and then to Fahrenheit, and then I add that temperature. What I do want to point out here is I'm using this dictionary writer, which is a lot like the dictionary reader for CSV files. And it allows you to basically create your own output file. And so I do this writer.write header. I'm basically writing the same header that the bike file had, but adding 2 columns to it. And then what I'm going to do is I'm just going to grab each row of data from the bike data, add its temperature and weather at that current point in time, pull that data out, and then write it all together. I did have to do some interesting little conversions here. The bike data times were in the format of like month, day, year, whereas the weather data was year, month, date. So I had to do a little bit of parsing there. And then I just wanted to ask a question about this was, how did the average ride length and weather condition apply? And so I basically ran this on a couple different outputs. How did the average ride length get affected when it was rainy versus when it was cloudy versus when it was clear? And I actually found some interesting results with this. So the last thing I'm going to show you for this example is just the output Excel file that I got from this writer right here. So I was writing each row of bike data with its new temperature and with its new temperature data and its new weather data. And I actually have the output file right here. I'm going to go ahead and pull it up to show you what it looks like. All right, and so you'll notice this looks a lot like the original bike file that I showed you, except what I have here now is I actually have 2 more columns. I have a column for the weather and a column for the temperature. And you'll notice that the temperature values are all the same for all these columns, and that's because they all start within the same hour. And so a lot of the data is the same, but it does allow us to analyze this file with a little bit more information. So instead of having to parse through and cross-check, we basically had our program do that. Again, so a kind of a cool application to a problem that we had. All right. So that is the CSV reader and writer. I didn't go into a whole lot of details on this stuff. The biggest thing that I would review if you're going to use this is review dictionaries. There's a lot of tutorials and stuff on this, so feel free to kind of just search like CSV reader, CSV writer, and you can kind of use it yourself. But it's very straightforward. You just open up the file and then use this CSV dictionary reader, and then if for whatever header you want to look at, you want to search for a file, you can do that, and it's nice and easy. All right. What I wanted to show you guys as for the second part of this was another library that we could use for Excel files, which is called Pandas. I don't know what Pandas stands for, if it does stand for anything. This is a much more powerful library, and I think it's pretty cool what you can do with it. However, if you are going to use this, you are going to need to add this library. So you'll go into your project interpreter, hit the plus sign, and then search for Pandas. And you'll hit the install package, and it will install that for you. So again, if you're using a school laptop, you won't be able to do this because you won't have admin privileges. So stick with CSV. If you have your own machine, you can certainly use this. Pandas might actually be on the software center, so feel free to look that up. You might also need XLDR, which is an Excel reader, if you're going to use this with Excel files. So one of the benefits of Pandas is that you can use it on xlsx extensions instead of just CSV files. Now, if you have data that's in an Excel file, you can export it as a comma-separated value file, but it will lose some of its Excel functionality. So you can still use CSV on Excel files, but you have to do an extra step. All right. So here's another application here that I wrote using Pandas. So again, you're going to have to import pandas, and then how do you open up a file? Same kind of idea, except here we don't use a read or a with open. We don't have to open it up anymore. We're just going to use this read Excel. So it's pandas.read Excel and then the file name that you're using. And what you're going to do is you're going to save this into a DataFrame variable. And so Pandas uses these things called DataFrames. The column headers are the DataFrame.columns. So this will give you the headers right here. So you can read in any Excel file and you can get its headers. This was like just a little check I added in here. And then you can go through each row by actually going through the data frame index. So each row has an index, row 0, row 1, row 2. And this is actually like the second row in the Excel file corresponds to index 0. So just going back to that Excel file that I had open before, if I open that up, so see how this is in Excel. This is this is row number 1, and this is row number 2, and row number 3. This would be the columns row. So if we say dataframe.columns, because these are the headers, and then dataframe 0 index of 0 would be actually row 2. Index of 1 would be row 3. So it automatically kind of converts this Excel file into having natural computer science like array or list numberings, if you will, where we start at 0. All right, so that's what this loop does here. And then let me explain what this little application I wrote was. So this actually was used for the grade verification process that our school did for marking period 3 just recently. So because we had to do this all online, the easiest way for teachers to verify their grades was with an Excel file. The grades were put into an Excel file and shared with the teacher, and the teacher had to make any changes necessary. Maybe a student turned in a late assignment and their grade changed from an 85 to an 86 because of that assignment after the grades were pulled. And so the teacher would then go and make that change in the Excel file. And then what has to happen is someone has to then go look through those Excel files, look at all the changes that were made by all 140 some teachers, and then actually input them into the system. So you can imagine you have hundreds of teachers with hundreds of students each. You can imagine how many grades you'd have to actually look through, how many Excel files you'd have to look through. And so what this program does is it actually looks through this directory, and this is actually another pretty cool thing you guys can look into if you want, is this OS library, or operating system library. This os.walk function allows you to actually look through an entire directory, seeing all the subdirectories, the directories, and all the files. So basically each folder, the way these grades were split up were in terms of department. So for example, math or science or English, and then in terms of each teacher had their own file. And so what this ends up doing is this just walks through all of the files, grabs the file name from that file so that we can go through and we can look at all these Excel files, and then we can just look for the changes. And so that's what this is doing here. So we're going through all the files here, and for each file, we read in the Excel data into this data frame variable. And then I use some try excepts here to basically see which rows had an updated grade. So what I'm doing here is similar to what we did in the last example with the dictionaries, where I looked for the name of the player. Here I'm looking for the data frame of the updated grade. And I'm just saying, was this grade upgrade? Was this file edited? So did it have a value for the updated grade? And so that's all you need to use for this. All right. So it's a very similar notation. And then I just do some checks here. Same thing with a couple other things here. And then basically all I'm doing is I'm outputting. So I'm creating an output data frame, and this is if you want to use pandas to make an Excel file, then you can basically create a data frame, and then for each object that you want to add, or for each row you want to add to this output file, you have to append a new row. So I'll show you guys a more basic example of this. And then here, right after we finish this, here at the end, we use the Excel writer to basically write out our Excel file and then save the file. And so this basically goes through about 130 or 140 Excel files, takes all the changes and puts it into one Excel file, making it a lot easier for the person that has to go through and find the changes. Okay, so let's do an example. So here, I'm back in the original file here. I'm just going to go ahead and comment out what we wrote for the CSV stuff. And this is using pandas. So we're going to import pandas as PD. This is the common abbreviation for pandas that I've seen online that a lot of people use. All right, and we're going to see if we can get our test.csv file read in. And so again, we're going to use this data frame variable equals pandas dot, and then we're going to type read Excel, and then our file name, test.csv. Okay, and I actually want to call this xlsx. So I have I basically have a second file. Looks a lot like my CSV file, but basically is it in Excel format instead of CSV. And then I'll go ahead and run this, and you can see it prints out this snapshot of the data in a nice tabular format. So you can see already that the output already looks nicer using pandas than it did when we were using our the CSV library. So that's one thing that's already just a little bit nicer. All right, so what can we do with this? So a couple of the basics. If we want to get the column headers, we can say df.columns, and we can print out those columns, and you can see it prints out the this dictionary of indexes: name, goal, assists, and points. So you can see you can get your headers this way. What else can you do? You can, if you want to go through it, you basically say for each row in your DataFrames index, you can print out, the row of data, and it will actually go through and it'll, oops, sorry. Yeah, well, it just printed out the row index. If you want to actually print out the, sorry, if you want to actually print out data in that row, so let's actually just call this variable I to make it make more sense, because I is actually just the index. So we would want to print out data frame of whatever we're looking for. So if we're looking for, let's say, the name of the player, then we would do that, and then of I, and this will just print out each of the names of the players. So a pretty similar feel to what we were doing before. You can basically append things to a data frame. You can remove things from a data frame. So this at this point is not editing the Excel file. So if I add something to this data frame here, if I say data frame append and a new row, well, what's a new row look like? You would have to have all of the basically all of the things that were in the original file. So a new row contained the name. So we basically are creating a dictionary of new data. So we'd Alice, Bob, Charlie, David. Let's maybe add Ed. And then we'll have goals be maybe like 12, and assists be 15, and points be 27. All right, and then what we can do is we can append the new row into this file, into this data frame. And so you can just continue to add data in this way. Whatever you're storing. If you are storing statistics for something and you have a new row that you need to add, then it's really easy to just add a new row, create a dictionary with each of the categories in it, and the value for each of those, and then you just append the new row. One thing you may want to add in here is this ignore index equals true. I forget exactly what this does. You can look it up. But it's so we don't get some sort of a bug in our when we're appending it. I forget. I'd have to look it up what it means again. Yeah, I think we can just see what happens. All right, so if we take it out, I think you get some error. So I don't exactly know all the workings behind that, but you can feel free to look that up if you're curious. Anyway, so and then the other thing you have to do is this creates a new data frame. So we have to say data frame equals data frame append. And then you'll see that we get the new data frame. And then we could write this to an Excel file. We could, do something else with this data, whatever it might be. If you want to write to an Excel file, it's pretty straightforward. You can use something called Excel Writer. This does require an import from Pandas import Excel Writer. And so you would use whatever output you would want, and then you would say output, or you would say your data frame to Excel, and then writer, and then you can specify what the Excel sheet would be called, and then there's another optional parameter here, index equals false, and then you would just say writer equals writer.save, and then when we run our code, you can see we get an output xlsx file here. And if I open this file up, let's go over. All right, and you can see it added in these numbers here to our Excel file. There's a little bit of formatting issues, but the data is there. All right, so that's a really, really, really brief intro into these two things. You can spend a lot of time exploring these things. You can do a lot of cool stuff with them. So maybe this is helpful to you. I mean, maybe you need to use tabular type data in your create task, or you have some application that would use that. And so I hope this video helps. You feel free to really research this stuff on your own. There's tons and tons of good resources out there. I just really showed you the intro of this stuff and just a couple applications of what you could do with it. But yeah, I hope you guys enjoyed the video, and I will talk to you later.